So Sam's wages increased from 14.50 to 15.37 per hour. Find the percent increase. Well, to find the percent increase, we first have to have the amount of the increase. So we have to take the $15.37 minus the $14.50. Subtract there, that gives us a difference of 87 cents. So then we define that percent. I have to shift my beard here into my mouth all the time. Percent, we have to figure out the percent of what? And the percent increase is always figured from the starting amount. Starting amount here is the 14.50. So our percent is blank out of 100 equals 87 cents out of $14.50. So we cross multiply and divide there. 100 times 0.87 divided by 14.50, 6. That is a 6% increase in wage. Does that make sense?
Yep.
Took some pictures because I'm going to need that.
Okay.
Even though there's a recording.
So today I promised we would do some applications of percent. And most specifically, that rate method of percents. Remember, the rate method of percents we said was mostly useful, most useful when you have the base amount. Remember, the base amount is that amount that all the other amounts are based off of. So let's say we are doing commission. Doing commission sales. Your commission might be 12% of net sales. Well, for a week where you have $8,200 in net sales, we could set this up as 12%. It's 12 out of 100. How much is that out of 8,200? We can set up that proportion and do it. The problem is if we're trying to do it quick, we have to set up that proportion. Proportion is tough to do in your head. It's one that you almost have to write it out on paper and calculate it. But if I want to use the rate method, the 8,200, the net sales, is the base amount. And I can just multiply by my rate. 12% as a rate is what? 0.12 is just the decimal form of the percent. So it's 8,200 times 0.12 gives us $984. So the commission for that week would be $984. Yes, sir. I think you had a question over there.
Why did you only do 82 in the calculation?
Because I did 82 and then just 12 instead of 0.12.
Oh.
So the two zeros I dropped off the 82 canceled out the two decimal places. I'm a little bit lazy, so I saved keystrokes on the calculator.
Makes sense.
It is the same thing. I should.
Right.
I do that all the time.
A little bit.
I've got to stop myself from doing that in front of the class sometimes because I realize it confuses people.
I'm like, yeah, okay.
Another place where the rate method is useful is in interest calculation. It's simple interest. And I'm going to start out with simple interest for 1 year. The simplest way to calculate simple interest. Now, first of all, simple interest is just that, the simplest way to calculate interest. In simple interest, interest is calculated only one of two situations. One, end of the term. So when we say simple interest for 1 year, we're assuming it's a 1 year CD or whatever. The account only lasts 1 year. Or two, there's an action on the account. What does an action mean? Well, an action means there's a payment into the account or a withdrawal from the account. Then before you can perform that action, you calculate the interest and add it to the balance before you perform that action. So simple interest for 1 year. I is the amount of interest. Dollars of interest. P stands for principal. Principal is the starting amount. Times R, which is our rate. And of course, that's the rate for 1 year. So let's say we invest.
Principal.
That,
What's the principal? Like, what is that number?
I have to give that to you in the problem. But it's the start. It's the number that you put into the account. Or if you're making a loan, it's the amount you borrow. Let's say you invest $2,500. The percents are pretty simple. 6% simple interest for 1 year. We've met the requirement that it's 1 year. The amount of interest, the principal here would be the $2,500. That's what we started out with. Times 6% is 0.06. $2,500 times 0.06, that'd be $150 in interest for the year. Not bad.
No, not bad at all.
We might have to invest $3,200 at 0.25% simple interest. One year. Find the interest. What are we going to do?
32 times 0.02.
0.225. There you go. Which is
Good question.
$72. Interest rate going from 6% down to 2.25% or 2.25% makes a huge difference. Less than half even though it's a larger principal, less than half of the interest rate, almost down to a third of the interest rate. So it's going to be way less interest, total interest. There's something called maturity value.
Isn't that after you have it in there for so long, like just gains?
Yes, that maturity value is the value at the end. Maturity is the end of the term. So the maturity value for this would be the $3,200 plus the $72. That would be $3,272. That's just for the 1 year, yes.
So we did 2 years on that.
Well, with simple interest, let's say it's other than 1 year. For simple interest, we can go for periods other than a year. It's just 1 year is the simplest. If the time is not a year, the amount of interest equals the principal times the rate, so that's still the same, times T is time in years. So if we're looking at for an investment for 1 year, T would just be 1. So this would be just multiplied by 1, which is not going to change it, right? So this is the same formula as before. It's just it was always 1 year, so that was always 1 before, so we didn't need. So if we invest, let's say we're going to invest $4,000 at 1.5% for 3 years. Our principal,
4,000.
4,000. What's our rate?
0.015.
Good. And our time?
Right.
3 years. Good. So multiply that out. $180 in interest. So 4,000. The maturity value, 4,000 plus 180. $4,180. Now 1.5% is kind of crappy interest. Let's do something more interesting. Let's say you're going to invest.
Aren't loans right now like 2%?
Home mortgages are like 2%. Auto loans are like 2.9 or 3.5%.
That's pretty low for right now.
It is very much so. Let's say you're going to invest $8,000 at, let's go 6% simple interest. For 4 years. Let's find that maturity value. Well, we first have to find the amount of interest. Well, interest equals, what's going to go in the formula?
8,000.
8,000.
Sorry for vanishing. I had to use the restroom.
Times the 4 years.
I got it right here.
What is it?
1,920.
$1,920 is correct.
Let's go.
So then the maturity value, the original $8,000 plus the 1,920, after 4 years, they're going to have $9,900.
Nice.
That's not a bad gain for doing nothing, just letting your money sit there. Because that is 6%, which is hard to find right now.
You have money in the stocks?
I do. We'll talk about that a little bit later.
Yeah.
I just like the fact that the hedge funds freaked out because of normal people.
Screwed it up.
They didn't really screw it up. They just bought stock,
Well, they did the opposite of what the hedge funds had expected, yes.
and they just.
Oh, we got to get rolling here. So
Yeah, I'm sorry.
Problem. This is for 4 years here. Normally, a bank does not like to do simple interest on something that's that long. Generally, 6 months would be the longest they would do simple interest. Some even like 3 months, or some even 1 month is the longest. Now, there are some things out there that you would not expect to be simple interest, but are, like your car loan. Everybody say, well, my car loan, that's like 5 or 6 years. Why would, I thought you said they didn't do simple interest for that long. Yes, but remember we said interest in a simple interest is calculated if it's the end of the term or action on the account. And what do they expect you to do on your loan every month? Make a payment. So you make a payment, they figure in the interest before they subtract your payment. So if you want to screw the banks, and a lot of banks now have made policies against this. What I used to do on my auto loan, that I'd get my tax refund, or I used to do some consulting work, so I'd get a bonus check from a company I did consulting work for. I would pay like 5 or 6 months worth of car payments ahead of time. Well, then I didn't have to make a payment for 6 months. Well, they didn't figure in the interest. I mean, yes, at 6 months, the next time I made a payment, all that interest got calculated in at once. but it actually does, they lose a few pennies every month by not adding that interest in every month. So it worked to my benefit, but a lot of places now, you're not allowed to get more than 90 days ahead on a payment. They just apply your payment to principal. They won't apply it to the next payment. Actually, a couple of banks I know of, you can only make that month's payment. You can only make a payment if it's within 30 days of due. They don't let you get more than a month ahead on your payments because of that, because people were doing that. At one time, my car, I didn't have another payment due for 16 months. So most of what they're doing is going to be shorter term. Like they might have, you might invest, and we're talking about investing rather than loans with the exact same calculation. Let's say you want to invest $1,500 at 8% simple interest. For 3 months. Find the maturity value, we first have to find the interest. So the interest is the principal of 1,500 times the rate of 0.08, our percent is a decimal, times, how do we express 3 months? We said the time was always years. What do you do?
0.03?
Thought, just make it a fraction, 3 out of 12. It's 3/12 of a year. So it'll be 1,500. 0.08 times 3 divided by 12. We don't have to enter the 3/12 as a fraction. We can just do times 3 divided by 12. We get $30. So that's $30 in interest. So then our maturity value, 1,500 plus 30, gives us $1,530. I used to do this calculation a lot myself. I used to run a construction company. You have those times where you didn't finish a job, but you had to make, it was payday. So I'd have to go to the bank and say, hey, I need $1,500 for 3 months or for 1 month or whatever. And yeah, it would cost me $15, $20, $30, but my guys got paid and they didn't go home unhappy. Well, let's go back to that example up here of $8,000 at 6% for 4 years. Typically, something that's 4 years, they would use something called compounded interest. Go for it. Compound interest, they calculate and add interest at scheduled intervals, scheduled periods. Like it might be monthly or quarterly or whatever. Let's look at that same problem. We're going to invest $8,000 at 6%. Rather than simple interest, we're going to go compounded quarterly. Quarterly means how often?
Every 4 months.
Every 3 months, yeah. 4 times a year. For 4 years. So to find this amount, we have to find the interest every quarter, every 3 months. So to do this, I'm going to make a little bit of a table here. We have quarters. We have the beginning balance. Interest of the ending balance. So for quarter 1, what's our beginning balance?
8,000.
Just our principal, $8,000. Our interest, that is 8,000 times 0.06 times 1/4 or 3/12, however you want to do it. You get $120 in interest. That means our ending balance is $8,120. We just add that to the $8,000. So we start the second quarter with $8,120. That interest would be, what's our principal now?
8,000.
Perfect. 8,120 times, the rest stays the same, times 0.06 times 1/4. Giving us $1,121.80 interest. So it's now $1,241.80 is earning that. Well, how many times would we have to do this to get to the end of 4 years? 14 more times. 16 total times. 4 times a year for 4 years would be 16 times. I don't want to do this 16 times. So let's look for a shortcut. The first thing I'm going to look for is this number right here. That appears every time for our interest. That's 0.06 times 1/4, which is 0.015. What that is saying is that this is 1.5% each quarter. So that makes sense, right? If it's 6% for a year, divide by 4 or multiply by 1/4, that's 1.5% per quarter. That makes perfect sense. Now next, let's look at back to some of the things we looked at on Thursday. We have that beginning balance. That we're going to add our interest, then ending balance. And we said each number is described by a percent and a dollar amount. The interest here is 1.5%, right? We know that the beginning balance is the starting amount. That's our 100%. Which means the ending balance is 100 plus 1.5 or 101.5%. Does that make sense? So what that means is to find the ending balance at the end of each period, we can take the principal, $1,000, times 101.5% as a rate is 1.015. If I do 8,000 times 1.015, I get 8120. That was my ending balance at the end of the first period, at the end of the first quarter. If I do that again, I take my 8120 times 1.015. I get 8241.80. Guess what? That was my ending balance at the end of my second quarter. How many times do I have to multiply by this?
16 times.
16 times. Well, in math, we have a shortcut. I'm going to multiply by the same number over and over. We can use an exponent, power. So we just do 8,000 times 1.015 to the power of 16. I get 10,151.88. Compare that to the 9,920 we had from simple interest. This is an extra $231. That's a decent gain for doing nothing more. But that's because that extra $231 is compound interest. Now the power of compound interest is time. How many of you are under 25 years of age? Under 22? 21? Perfect. Let's say start at 22 years old. Retirement age right now for full Social Security is 67 years old. Chances are by the time I get there, it's going to be over. They've actually said they're going to raise it before I get there. By the time you get there, who knows what it'll be. But for right now, let's just go 67 years old. How many years is that? 35 years. Now, I'm not talking about going to the bank, because the bank's only gonna give you 1.5%, 2%, you know. Not really, if you go to a professional investment advisor, they can invest you in mutual funds or stocks or whatever. If you leave your money in there for 45 years, what do you think you can average for a gain each year? Well, the average 40-year gain in the stock market, this is 40-year periods even that include Great Depression or the big crash in 2008. The thing about a big crash like the Great Depression or 2008 is they tend to be followed by a recovery, and recoveries are rapid gains. The average gain is between 12 and 13%. So, should we just go 12% to be conservative? So let's say you can go to an investment planner and they can get you 12% per year. So that means start off the year with 100%, you add 12%, so you end the year with 112%. So if you take your starting amount and multiply by 1.12, 112%, right? Now, let's talk about this. I'm going to put that in the power of 45 because it's going to be 45 years. Right now you're in school, maybe living with parents or family, living cheaper, driving that old car or whatever, trying to squeeze a few more miles out of it. A lot of people, they get done
Walking.
you get that first good job, they've got money coming in. Two things. One, they want a new car or a new truck. And two, they want to move into a nicer place to live, or a nicer, more private place to live. But let's just say you hold off on that. You stick living where you're at, living cheaper like a college student, drive that old car for another year or two. How much money do you think you could save up in that first year? Good. 20 grand? You probably could if you really went after it. Let's just, to make sure it's something you could do, let's say 5 grand. The reason I say 5 grand is actually up until about 3 years ago, $5,000 was the amount you were allowed to put away every year in IRAs. Now I think it's up to 6,000 or 7,000. They've raised it. So you put that $5,000 away at age 22. You let it sit there until 67. You got your investment planner managing it for you. Anybody want to guess what it'd be worth at age 67? You want to guess?
Is it to the power of 67 or 45?
To the power of 45. Thank you.
Yep.
I was going to really make it go big. $819,938. From one $5,000 investment. That was at age 20. Now let's say you get out of college and say, darn it, I have worked hard. I want my new truck. You know, I want four-wheelers or whatever. I want to move into a nicer place. I'll wait, I'll start saving later. So you're 32. Finally paid off that new truck. Now it's time to worry about retirement. So now you put away $5,000. Now how many years is it going to have to sit there? 10 less would be
35.
5. Anybody want to guess at what this number is going to be? $263,998. One-third of what you would have had if you put it away at 22.
Ooh.
Now, I'm 47 technically. Let's say you wait until you're 42. You're not quite my age. That's going to only be 25 years. You got it. $5,000. Compare that money at 42 compared to what it would have been if you put it away at 22, almost 10 times as much. Now, that's just putting $5,000 away once. Since we've got a little bit of time here, let's play with some numbers a bit. I'm going to do it the easy way by doing an Excel spreadsheet.
Adding money, it'll keep growing.
Yes, you can keep adding money to that and it'll keep growing for you, yes. Get back here. Enlarge this a little bit so you can see it better. Let's say this starts you out at 21 again. Let's get you all the way up to 67. Pick a number that you want to invest for retirement every year.
I'll give you a real number because I have real number.
Do you invest every year?
Not in every year, but I have a starting balance.
What's your starting balance?
I don't know. I texted the person that knows.
Well, sure. Well, your starting balance, let's say your starting balance is $10,000, it would just be double with the $5,000. So $5,000 would give you about $820,000. So let's just say you can save, you want to keep going with 5 or go a little less?
Let's go. Why don't we just go with you've invested $500 a year?
$500 a year isn't much. Let's go a little more than that. Let's go $2,000 a year.
Go 2.5.
What?
I feel like that's doable.
Well, you can figure $200 a month is not bad.
Yeah, I think if you got a $1,000 check and you're only putting 200 away, not good.
200 a month is $100 every paycheck. That's not terrible, right?
No.
I know people that waste that much going out to drink after a payday. Seriously. I may have done it myself when I was younger. So the balance here decimal point in there. These are the numbers. Anybody want to guess? 2,400 a year. 2167.
Ooh,
4 million.
4 million.
You could survive off of that.
Maybe. How am I supposed to feed my family of $4 million?
Now let's watch this. This person here at 21 says, you know what? I'm going to save up. And I'm going to save until I'm 28. That's 8 years. And they say, you know what? At 28, now I'm going to start playing with my money. Everything I earn, I'm going to buy toys. So they wait till 28 to get that fancy truck or that new snowmobile or four-wheeler or boat or whatever. Do I want to guess? They still have $2.5 million. Only saved for the first 8 years. What? Now this person over here says, screw it, I'm young, I want my toys now. They save nothing for those 8 years. They start saving at 29. Want to guess there? 1.6 million. It's ridiculous, but it's the truth. That first, your 20s, whatever you save in your 20s is worth more than what you save for the rest of your life. That first 8 years of investing, you start working, it's worth more than investing that same amount every year for the rest of your life. I know that seems nuts. This person invested literally, 8 times 2,400? Less than $20,000. $19,200. Ended up with 2.4 million. This person invested $2,400 every year for 40 years, literally invested $96,000. Only gets 1.6 million out of it. So which would you rather do? Buckle down for 8 years when you're young, and then play with your money for the rest of your
What
life?
about 9 years?
Do another year?
How much would it be?
So I'm gonna go 9 years there, and I'll turn this one to 0.
Yeah.
0.6. I mean, obviously this over here is the best scenario, to just pick a number and keep doing it from now until the day you retire. But still, you can see that first 8 years was 2.5 million of that. The last 40 years was 1.5 million of that $4 million. I mean, it seems ridiculous, but it's the truth. What you can save in your 20s is worth more than what you'll save the rest of your life. I'll get off my soapbox now. You know, like I said, I'm going to a bank. Go to a professional investor like Fidelity Investments or State Farm or Edward Jones. The key term is fiduciary. Fiduciary is somebody, they get their commissions if you make money. Some other investment people and investment brokers, they make money when you buy whatever. It doesn't matter to them whether you make money or not. They make money by selling you a product. The fiduciary, they only make money if you make a product. Okay, now before we get, I'm sure there's going to be a side conversation here. Before we get into that, I'll give you the homework, page 97, 1 through 13. We did not go over every problem in that, so we're going to have to go over more of this tomorrow. We'll go over how to calculate loan payments and stuff like that tomorrow. We'll look at what that $50,000 truck really costs you and the importance of good credit. So some of those problems you won't be able to do because it'll ask you for what's the payment or what's the amortization of a loan, stuff like that. We'll go over that tomorrow. Any questions?
Well,
Nope.
since Thursday's a test, if we do the test before Thursday, do we
Then you'll have to show up. Realistically,